Write a word problem for 1.3 times 2.79. Use our definition of multiplication to explain why your problem is a multiplication problem. Solve your problem without using a calculator. Okay, so we're going to start with the form of the definition. So we have 1.3 groups and 2.79 items per group, units per group. And we need to ask a question for a total number of items, whatever these are, right? And what we have then, generally, we use weights or we'll use money, right? When we're looking at multiplying decimal numbers. So for example, we could have something like $2.79 per pound, right? Per pound. That would be then 1.3 pounds that we're buying. And we're asking then how much money are we spending, right? So as long as we set our question up to match this equation, we'll have explains why our problem fits the definition. So let's see. Cherries cost $2.79 per pound. And we get 1.3 pounds of cherries. How much money did we spend? And now they want us to multiply or solve the answer without using a calculator. Okay, so that means we're going to practice using the stacked algorithm and the uses of, well, we ignore the decimal places. So we treat these like whole numbers. And then we multiply as if they were whole numbers, right? So 3 times 9 is 27, right? 3 times 7 is 21, 23. 3 times 2 is 6, 7, 8, right? Show your carrying. Now we skip a space because we're in the 10 spots. We have 9, 7, 2, add straight down. 12, carry the 1. Actually carry it though. That was a hard carry. Let's see. Try that again. And then 15, 16, carry it. Carry the 1, gives me a 3. Now I went and multiplied by 10 3 times. Now I have to divide by 3. I mean 10 3 times. Okay, so going back, I'm going to put this in a smaller font for you. So we did times 10 to ignore the decimals. And we did times 10 to ignore the decimals. So to undo it, right, to get back to the actual place, but I'm a little close, we're going to divide by 10 3 times. And as a result, we can see our decimal place is at the 3.627 because we're going to divide by 10, divide by 10, divide by 10 to recover. Okay, so that's how we multiply in decimal form. The workings behind ignoring the decimals and treating the values as if they were whole numbers, and the process of recovering how many decimal places to put your decimal point when you return from this gigantic multiplication here. So in the end, you round to the cent location. So we spent $3.63 after rounding, but you will still want to show the answer before rounding, especially to prove you did it by hand, right? That type of thing. So solve your problem without using a calculator. Another way that we show the standard algorithm working, in addition to this side method here, we also do improper fractions, right? As a way of showing, let me write it down first, as a way of showing the ignoring the decimals and multiplying as if they were whole numbers part of the process when we multiply decimal numbers. Okay, so 1.3 times 2.79 is the same as 13 over 10 times 279 over 100, because we have 1.3 tenths, right? What, not 1.3 tenths, but 1 and 3 tenths. And we have 2 and 79 hundredths, right? So we have 13 tenths and 279 hundredths. All right, so now our standard algorithm for multiplying fractions says that we multiply 13 times 279, and then we will divide by 10 actually 3 times, where 100 itself is the quantity 10 times 10. So just like we saw in the stacked algorithm, when we ignore the decimal, let's back up and restart it so that I can show both having the same actions. So at first, let's just stick a 1 under these numbers, because every number, right, can be thought of as implicitly over 1 and then be turned into a fraction form. So now we have these in fraction form, our first improper fraction. Now, to get the 1.3 to the form of a whole number, we're going to multiply the top by 10 as well as the bottom, right? And to get, to get the 2.79 to a whole number, we multiply by 10 twice, right? We're going to multiply by 100, which is 10 squared. And so we have 10 squared on the bottom as well. And then we get to the point where we have 13 times 279 on the top and 3 copies of the 10 in the bottom, right? Which often is just written 10 to the power 3. Okay, so now you can more clearly see when we wrote, let's write it, 2.79 times 1.3, we said multiply by 10 gets me to 279. Multiply 1.3 by 10 and we get to 13. And we can ignore the decimal places and multiply these as if they were whole numbers, right? And as a result, right, I'm going to use a calculator this time. We had 279 times 13. We have the answer 3627. And then we said, because we arrowed over to the right 3 times, we're going to arrow over to the left 3 times, moving our decimal place 3 places to the left at the 3.627. Now, in our improper fraction algorithm, we have a numerator of 3627. And we will be dividing by 10 to the power 3, which is 1000, getting us the exact result of 3.627. So these are 2 different methods showing that the standard algorithm, let me catch up, which we don't even discuss really, we just do it, right? The standard algorithm in words is to ignore the decimal places, multiply as if they were whole numbers, then count the number of places you ignored to insert the decimal point that many places to the left of the rightmost digit, right? But these are 2 different methods of showing that algorithm. One being improper fractions. So here's an improper fractions method. And the other being this stacked algorithm version, which is very similar to how we actually write it, right? When we write the multiplication, we just ignore, like literally ignore it, then count and put them back in. But because we are trying to illustrate what it is we're ignoring, right? Then we need to show why it is that we recover putting the decimal point three places to the left of last digit, right? So it shows there in that algorithm, and it shows here in this algorithm. But both methods show that the standard algorithm of ignoring the decimal points, multiplying as if they were whole numbers, and then counting the number of places to put your decimal point back into place. These two methods show why that works. All right.